All right, everybody, welcome back.
Yeah.
I am so pumped for today's deep dive. We're tackling something that, well, it's a big one, folks.
Oh.
Alzheimer's and dementia.
Yeah.
And I think it's safe to say we all probably know someone, a family member, a friend, maybe even ourselves, who've been touched by these diseases.
Absolutely.
And honestly, let's be real, current treatments,
Yeah.
they can be really expensive, they're not always that effective, and some of those side effects are a real punch in the gut.
It's true. It's a tough situation, and unfortunately, more and more people are facing it every day.
It's scary.
Yeah.
But there's some light at the end of the tunnel. Researchers over at Washington University in St. Louis are doing some really amazing things, like potentially groundbreaking stuff.
Yeah.
They're working on a vaccine for Alzheimer's and frontotemporal dementia.
Wow.
So today, we're going to buckle up and dive deep into the science behind this. I'm really excited to see if this could be the answer we've all been hoping for.
Yeah, me too.
Now, to help us navigate this pretty complex world of cutting-edge research, we've got a real expert in the house. Welcome.
Thanks for having me. I'm happy to be here.
All right, so before we even get into the specifics of this vaccine research, I think it'd be helpful to take a step back.
Sure.
Can you kind of just paint a picture for us, like what actually goes wrong in the brain when these diseases take over?
Well, you're absolutely right to point out how devastating these diseases can be, and sadly, they're on the rise.
It's true.
At their core, both Alzheimer's and frontotemporal dementia involve the buildup of certain proteins in the brain,
Okay.
specifically amyloid beta and tau. Now, think of these proteins like tiny building blocks. They're supposed to help brain cells work properly, but in these diseases, they start to misfold and clump together.
Oh, wow.
And that disrupts the intricate communication networks within the brain. It's like a traffic jam on a cellular level, and that's what leads to the cognitive decline we see in these conditions.
Wow, that's a really powerful image, the traffic jam. It really helps to understand why these diseases are so debilitating. And you mentioned that existing treatments aren't always very effective. What's different about this new research? How could a vaccine possibly help with something like this?
Well, the really exciting thing here is that instead of directly attacking the protein clumps themselves, which is what a lot of other treatments try to do, this new research is focused on harnessing the power of the body's own immune system to clear them out.
Interesting.
And the way they're doing that is through a vaccine.
Oh, wow. Okay.
Yeah, so it's a totally different approach.
So it's like we're not trying to fight the fire ourselves this time. We're giving the body the tools to be its own firefighter.
That's a great analogy. That's exactly what they're aiming for.
That's incredible.
And a key part of this whole thing is the use of this special nanofiber platform developed by researcher Jai Rudra.
Nanofibers. Okay, that sounds pretty high-tech. What's so special about them?
Well, one of the biggest hurdles with previous attempts at developing dementia vaccines has been this risk of triggering too much inflammation in the brain.
Oh, I see.
It's like the immune system overreacting, you know? It's like sending in an airstrike when you really just need a SWAT team.
Oh, yeah. That makes sense. Too much of a good thing.
Exactly. And that's where Rudra's nanofibers really shine. They're designed to deliver these pieces of the harmful amyloid beta and tau proteins to the immune system in a way that triggers a very precise controlled response.
Oh, well.
Without setting off that dangerous inflammatory cascade.
So it's a much more targeted, a gentler approach almost.
Precisely.
Okay, wow. This is sounding really promising. Where does the research stand right now? What's happening with it?
Well, the team has been collaborating with other researchers at WashU, Tim Miller and Kathleen Schoch, who are real experts in using animal models to study these diseases.
Okay.
And right now, they're testing the vaccine in mice. They're looking at its potential both for preventing the disease altogether and for treating those who are already showing symptoms.
So there's hope for people at all stages of the disease, potentially.
That's the hope. It's still early days, but the initial findings have been pretty encouraging.
Okay.
And the team is really hopeful that if this vaccine proves successful, it could be used to prevent the buildup of these harmful proteins in the first place.
Wow.
Essentially protecting people from developing dementia altogether.
That would be incredible. Truly incredible.
It would be a game changer.
It really would be. Now, I know that WashU is really committed to tackling dementia from all angles, right?
Oh, absolutely.
This vaccine research is just one piece of a much larger puzzle.
You got it. They've got this multi-pronged approach.
Right.
It involves developing new ways to detect these diseases early on, things like blood tests for neurodegenerative diseases. And they're also exploring lifestyle changes that might help reduce the risk or slow the progression.
It's just amazing to see so much energy and effort being poured into this. So I just want to summarize what we've learned today. We've been talking about a potential breakthrough in dementia treatment.
Yeah.
And this breakthrough involves a vaccine that uses nanotechnology to basically train the body's own immune system
Yeah.
to get rid of those harmful proteins that cause so much trouble.
Exactly.
Now, it's important to remember that this research is still in its early stages,
Right.
but it's really promising. This has been a truly fascinating deep dive. It's incredible to think that we might be on the cusp of something truly revolutionary in the fight against dementia. Thank you so much for walking us through all of this.
My pleasure. It's been a great conversation.
And to everyone listening, thank you for joining us on this journey of discovery.
Yes, thanks for listening.
We'll keep you updated on the progress of this research as we learn more. And we'll be back soon with another deep dive into a topic that's sure to spark your curiosity. Until then, keep those brains buzzing.
Take care.
Bye, everyone.
Bye.
See you next time.
Sounds good.
Well, looking forward to it.
Okay.